Welcome back to the ChemDoctor, and this would be the sixth video in the series on chemical kinetics. And specifically, what I want to focus on here is finding the instantaneous rate for a set of data that follows the decrease in concentration of a reactant over time. The reaction that we're following is the reaction of N2O5 to produce NO2 and O2. And we have a simple set of data over here on the left that relates how the concentration of N2O5 is changing with time. On the right, what I've done is I've plotted the graph of the same data, and you can see that it follows the same curved sort of graph that you expect for the decrease of a reactant over time. Now, in terms of finding the rate of a reaction, we can write the expression for the N2O5 this way. We're going to use a negative sign to indicate that the concentration is decreasing with time. We have delta and then square brackets N2O5 to indicate the change in concentration of the N2O5 over the change in time, and this is going to equal the rate. Now, the viewer needs to realize that essentially this rate is the slope of a tangent line that we take anywhere along this graph. And the bigger the interval that we take on the tangent line, the more, I guess the way to say it would be, the more average this rate, and the more inaccurate that rate is for the interval that you're looking at. The closer the points are that you take, the more accurate that rate is going to be for a specific point that's on the line. And the closer we get that interval, the closer we get to the instantaneous rate. Now, if I was to break this expression out so you can actually see how we're talking about the slope, because remember, the slope of a line is equal to y2 minus y1 over x2 minus x1. So if we break this expression out so that it reflects that, then it would be negative, and then inside this quantity we're going to have the concentration of N2O5 at T2 minus the concentration of N2O5 at T1. Okay, and then this is going to be divided by T2 minus T1. So what I want to do in this video is show how we find an instantaneous rate, and that's going to be basically this expression at a single point that we're interested in, at a single point. And the point that we're going to choose here, so here's what I've done. This is hard to do by freehand, so previous to the video I set up my curve, and then I carefully used a function to draw a tangent. And it's not the most beautiful thing in the world, but the point of interest is this one right here. So my tangent was drawn as carefully as I could to lean against the line at this point. And that point is this time frame right here where we're at literally 300 seconds. So I'll pull that down. So we're at a point that's at 300 seconds here. So now that once we've established the tangent, then all we need to do to find the rate right here is get the slope of this tangent line. And the 2 points that I've selected to do that are going to be here. So I'll bring this over and I'll indicate this point down here with an arrow. Okay, and that point, I'll put the coordinates up here at the top, will be 200 for the T2, all right, or T1 actually, and then 200 seconds, and then the Y value is going to be 0.875, all right. The second point that I'm going to utilize is going to be about right in here. And I'm calling this 530 seconds. So I'll write that down here so you can see it clearly. All right, and that's going to be about here. on the line. So the y value is going to be 0.7, this guy right here. All right, so let's go ahead and get that set of coordinates. So it's going to be 530, comma 0.7. All right, so now we've got our two coordinates where this is T1, this is Y2, or Y1, excuse me. I always want to do that. This is Y1, right? And then down here we're going to have T2, and we're going to have the Y2 function. All right, so now let's go ahead and calculate the instantaneous rate. So the instantaneous rate is going to be equal to, all right, so it'll be 0.7 minus 0.875 divided by 530. Oops, get that right. Okay, so 530 minus 200. All right, and what I get for the instantaneous rate is going to be 0.000. Let's see, I've got 4 zeros here, so it'll be 5303, and the units are going to be in molarities per second. All right, so that's how we get the instantaneous rate. This is the instantaneous rate at this point. Now, in an AP chemistry class or a general chemistry class, what are you going to be expected to do? All right, they're not going to expect you to do calculus at that level. What they do expect is a solid background in algebra. So basically the scenario that I imagine is going to be that you're given a curve and you either have to use a graphing calculator or you've got to use the old-fashioned method, which is what I did, where you get a piece of paper out and a ruler, you draw the tangent to the point, and then you select 2 points on the linear tangent, and you find the slope of that tangent line, and that's the instantaneous rate at the point where you drew the tangent. All right, so that's the deal on instantaneous rate, and with that I'm going to go ahead and close this video.